So with that, thank you, and I think we're on to our next speaker.
Yes, thank you so much. And I believe you had a session at Ignite as well that was recorded?
Yeah, we had a couple different panels on responsible AI that I would definitely recommend checking out. And we released some of our practices and capabilities around spatial analysis with more details on sort of how we did it. So that's another great place to look.
Great. So I encourage everyone, if you want a little bit more, there were so many questions flying in while you're speaking, that to check out the Ignite recorded sessions, and Sarah's already delivered a lot more of that information. That was great. So we're moving on to Devakti. Thank you for joining us about crowd AI and what you're doing in government.
Of course, thank you so much. What I'll do is now flip over and do a screen share, so bear with me. Great. Everybody could see my screen?
I don't think it's in presenter mode yet. There we go. Thank you.
Thank you. Fantastic. Well, thank you so much for this opportunity. My name is Devaki Raj, and I'm the CEO and co-founder of Crowd AI. It's really an honor to be among such an accomplished group of speakers tonight, so I'm really excited for the panel later. So today I want to speak to you a little bit about how we, as a small company, enable the US government to build and deploy computer vision models. I'll talk to you about our relationship with the US government, but more importantly, how we translate a product that we built for enterprise to US government needs. At Crowd AI, we're on a mission to put the power of AI in the hands of everyone, even if you aren't a data scientist or an engineer, or even have the resources of having data scientists or engineers on your team. Our platform can be used to create AI for visual analysis. That is, we help users create computer vision models to extract meaningful insights from unstructured images and videos. So we've built a platform to be imagery agnostic from the start. So this means that all types of imagery could be adaptable to our platform: electro-optical, infrared, multispectral, aperture radar. And this data comes from a variety of different sources, including cell phone camera imagery, drone imagery, aerial, and satellite. So for the last 4 years, we've worked with the US government on a bunch of different, very exciting efforts, from full motion video analysis of wildfires that are currently being deployed over the wildfires right now in California, to aerial and satellite imagery for building maintenance, road damage, anomaly detection, and humanitarian aid disaster relief. So I'll show you some examples of that later. So having worked with a variety of stakeholders across the US government, we realized that there's no one-size-fits-all approach when it comes to computer vision. So which is why we set out to create a code-free one-stop shop for computer vision, specifically for highly customizable computer vision. So at Crowd AI, we're really a firm believer in creating tools that make machine learning more approachable and intuitive for everyone. So our machine learning team is constantly conducting research, publishing papers at CVPR and NeurIPS on new and cutting-edge techniques that we can incorporate to help our users get the most out of our visual AI platform. So many people and organizations right now are using imagery and video to make decisions faster. But what we realize is that a one-size-fits-all approach for machine learning really doesn't get the job done anymore. So what exactly do I mean by that? Each person and team that looks at images and video to understand the world often takes a slightly different approach in doing so. So how does that actually translate? Especially when building computer vision models. So for example, consider this aerial imagery that was taken right after the tornadoes in Tennessee earlier this year. Two different people may look at this image and draw separate conclusions about what they deem building damage. So for example, a person that works at FEMA that has a set ontology may consider a different set of extreme to non-extreme building damage, or a person that works at an insurance company may have a different criteria of what they consider extreme or very low damage. So for instance, do these two houses in the red box have high or low damage? And what about the neighborhood as a whole? How are you classifying damage? The individual preferences and definitions users bring to image analysis is really what makes customized machine learning so powerful. You essentially have the power to train a model to analyze the imagery the way that you would prefer. So if you use an out-of-the-box model trained by someone else, the way the model would analyze an image wouldn't necessarily match your own definitions, right? Because potentially these models were trained over a different AOR or trained with slightly different definitions, or there's been a domain shift over time. So CrowdAI has built this visual AI management system that offers a complete end-to-end platform that enables our users to incorporate their individual preferences and needs when it comes to building computer vision models. And our platform is comprehensive, but having been built with the US government in mind, it's also modular. And this really enables users to employ only specific components rather than the whole system if that's the route that they prefer to go, all while maintaining interoperability with any other existing tools in their AI stack. I mean, we've spoken with various government folks, and sometimes they've got their own in-house labeling tools that they prefer to use. And so instead, we can deploy the other modules that help make a seamless computer vision experience. So our toolkit includes annotation tools for full motion video and still imagery, data management, worker management and quality assurance of the training data, model training based off of custom models that CrowdAI has built after years of domain-specific R&D with the US government, model comparison tools to identify the best types of models to deploy, testing tools, automated model deployment. But it also, more importantly, includes the ability for continuous production feedback from the end user, i.e., once we've created a model through the platform, the user can then determine if the output of the model is up to the standards or the definitions that they have. And if it's not, provide feedback on individual instances. And then that goes back to the training data scheme to continuously improve the model based on the definitions that the customer wants. And this could be deployed on premises. But thanks to Microsoft Azure, it could also be scaled across the US government securely and seamlessly. And we'll talk about the pros and cons around on-premise deployment versus cloud deployment when it comes to AI, especially in the US government. So our customers across the US government work with us in multiple different ways. And obviously, kind of the entire, the audience here potentially is probably at different stages of how they think about their AI roadmap, how they think about computer vision. And so we have customers that, one, potentially come to us and don't even have imagery or video, but are considering starting to collect their own imagery and video. And then some of our customers have analysts that are creating their own version of training data in their own types of platforms that they've been using day in and day out, looking at imagery, drawing boxes here and there. But often, using these tools, they have gaps and shortcomings in their ontologies or annotations. And they don't really have an understanding of the importance of building positive and negative data sets. And some of our customers may have the training data that they've built, but they don't have the expertise to train the models. So they tend to rely on third parties that use off-the-shelf models that have been trained on out-of-domain data. But then finally, you've got the really sophisticated users that have built relationships with third parties and have built their own models. But ultimately, they don't have a way to retrain or productionize these models, and it's often stuck in R&D. And retraining is really important to make sure that the model continuously is exposed to, in-domain data, exposed to kind of the proper questions that you're trying to solve. So that's why, in addition to our platform being modular, so too is our strategy. So we work with customers to build top-performing models for clients, kind of deploy our platform for customers and assist them in building computer vision models. And we also help them deploy our platform to use on their own. So now that I've given you a high-level overview of our platform and our approach to working with the US government specifically for computer vision, a lot of this has been supported by our use of the cloud, specifically with providers like Microsoft Azure. So I thought I would dig a little bit deeper into the platform itself and how we could potentially work with users to kind of build computer vision models without having to look at code or having to understand the underlying code. So here you could see a home dashboard screen offering project metrics and statuses, but let's dig in a little bit deeper. As I mentioned before, this platform is specifically focused on computer vision, and that's our specialty. So our platform can solve three major types of questions that often comes up when you're trying to solve computer vision questions and answers when you look at imagery and video. So classification, is there a dog in this image? Bounding box, where in the image is the dog? and let's draw a box around it. Or segmentation, which exact pixels represent dogs in this image. So our customers can come in and choose a type of model that they're interested in building. However, a crucial and often overlooked component of great machine learning is really a dedication to very strong data management. Our platform allows users to connect their existing Azure account and immediately start exporting relevant images and video that they wish to build custom models off of. And we're also deploying in-browser machine learning tools that expedite the process of sorting, tagging, and then visualizing data sets. Also just as crucial is we've included a simplified yet powerful ontology guide. And this is really important, especially in the US government. We've often noticed that the lack of common ontology across multiple US government groups means that there's no common way to access the wealth of training data across other counterparts. And this is really the key to making sure AI could scale across multiple different USG agencies. That being said, we understand the need for often on-premise deployment due to security concerns, but that often limits the sharing of these joint ontologies. But as we shift towards cloud, especially with providers like Microsoft Azure, these ontologies should be carried across more seamlessly while still being able to maintain security requirements. So we built a variety of different tools, and I'll quickly whiz by them. We've built annotation tools, both for imagery and video, including tools to automate annotation to decrease manual repetition. Our web-based annotation tool really includes many quality of life features, which is really important when people are looking at imagery and video day in and day out. So we've got shortcut keys, magnetization, Mapbox integrations to really help improve the experience of annotators. Because ultimately, high quality annotations lead to higher quality data, which lead to higher quality models. So we've also built tools specifically that carry over to our video annotation interface. Annotating thousands of hours of video means that annotators and analysts are creating millions of labels for millions of frames. To make this easier, we've incorporated interpolation tools, which means you essentially could automate a lot of annotation between two keyframes defined by the user. So decreasing the amount of work that it takes an annotator to fully review a video tremendously. And finally, once our users have created sufficient amounts of training data, we automatically kick off the best types of models to train based on scraping the metadata of the training data that the user created. And so we've got a bunch of tools for users to visually compare models. And we believe that visualization is really, really important because it helps users identify models that best suit their needs. Obviously, one can rely on precision F1 recall scores, but they often do not tell the full story, especially for very visual use cases like computer vision. For instance, we've noticed that some of our users are more tolerant of false negatives, but are absolutely not tolerant of false positives. And so by choosing the correct model from a visual standpoint, it's much more easy for an analyst to choose the best model depending on the particular problem that they're trying to solve. So the final model, once a user has gone through the entire spectrum of training data to model building, to model comparison and choosing the best model, a final model can then be exported directly in a model container, or model outputs can be accessed directly via an API. So in front of you is an example of a model that was created on our platform that identifies the perimeter of a fire line in real time on drone footage on near infrared data. So what you see right here is the raw output of a model running, again, at 30 frames per second, identifying the highest confidence edges of where a wildfire is. So this is the example of the wildfire model we built with the Jake, and we deployed it in a container within the government environment. However, that's not where we want to end, right? I think having high quality machine learning and deep learning is really important, but having users be able to interact with it and give it feedback is really the way we actually get AI and computer vision to scale within the US government. So the model that I just showed you previously is just a portion of the entire fire line. So instead, what we've done is we've integrated our model into end user systems in which it maps all of the polygons that the model is continuously generating And it's mapping the highest probability polygons onto maps to map the entire fire line over an entirely grand area that one pass of a aerial flyover can't do. So we're actually actively working on integrations with all of the major US government end user platforms, including ATAC and DART. Because again, we don't want the model to be stuck in an R&D project. We want to continuously learn from end user feedback. So here you could see that the polygons are outputting and the highest probability masks are mapped together. And then here you could see a comprehensive map of wildfires, the exact size of the wildfires, and if there are any offshoots of wildfires, such as spot fires. And that's obviously very important to have in real time, especially now as well as the wildfires are raging. So I wanted to quickly walk through a handful of previous use cases of how our platform was used specifically in the US government, and specifically how to use our platform to build custom models with our customers. So with the rapid growth of commercial and geospatial imagery, now this includes satellites, aerial imaging, there's really an enormous opportunity to build models that automatically extract data for a wide variety of use cases. So using our custom-built image segmentation neural nets, we've trained models to help commercial as well as government customers leverage all types of imagery and video. So I'll go through a couple of examples. So this is an example of a real-time vehicle segmentation model on commercial drone video. In this video, you'll see the sequence 3 times. So the first pass is just a raw footage. The second is what we call a heat map, very similar to what you saw in the fire line. And it's a visualization of the model's per pixel confidence scores, colorized with red being the highest confidence outputs. And finally, the post-processed binarized output in blue and white. Here we see an example of using image segmentation to understand road networks. And really for understanding road networks, bounding boxes and classification really don't work. You have to really understand where exactly the roads are and kind of map the exact edges of each of the road. And really segmentation is the only way to solve that. So on the left, we have built a model using our platform off of commercial satellite imagery to differentiate between paved and unpaved roads. And this is an AOR that's outside of the US. On the right, the model is even more advanced. By using non-imagery context clues that we bake into the labeling ontology, we could teach a model to label roads not just by how they look, but by what function they serve, such as a highway, a side street, or even a road within a parking lot. And the same idea can be borrowed into the humanitarian aid and disaster response sphere. Here, we used imagery from Planet to automatically label flooded roads during Hurricane Harvey in 2017. So green are roads that are not flooded, and red are roads that are flooded between pre and post imagery. In that same domain, our building model for NOAA has been deployed to analyze hurricane impact at the city and even county level. And again, this is where ontology is really important, because FEMA may have different levels of damage from roof tile missing to entire building destroyed, versus another agency in which it's really important to identify if parts of, for example, the Air Force or the Army civil engineers, it's really important for them to identify if there's ponding on a roof or if there's peeling of tarp off the roof. So it's really important that the platform is flexible for a variety of different ontologies based on what question you're trying to answer. Here's another example of why we're such big fans of image segmentation. So when counting ships in a crowded marina, image segmentation allows us to detect individual vessels and label them separately, something that if you throw so many close objects together, traditional bounding box approaches often struggle with. And finally, here's an example of dual use commercial technology. So on the left, the model was trained to look for oil and gas pads in the Permian Basin. In fact, it was looking at 44,000 square kilometers of the Permian Basin on a weekly basis. And we're looking for any changes to pads for a commercial customer. but the same approach that can be used to bootstrap a model for a government use case, such as identifying deployment sites for broad area search use cases. And to keep pace with the ever-evolving imagery world, we're continuously adding support for new sensor types into our platform. More recently, we've added support for synthetic aperture radar, or SAR, which is obviously very useful to see during clouds, and especially being useful right now over the wildfires. So these are just a handful of potential use cases that we see. Many have been highlighted in greater detail on our blog, and if you go at crowdai.com. Thanks for joining and hearing about how CrowdAI enables the government to build and deploy computer vision models. We really wouldn't have been able to have the impact we would do within the government without cloud providers like Microsoft Azure. And so we're excited to continuously deploy in Azure for future government users. So if you have any questions about our talk or want to learn more about our platform, please feel free to email at hello@crowdai.com. Thank you so much.